Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni and today we are going to discuss another topic from the chapter which we have started in the last class, and that is the is matter around us pure. Name of the chapter is just give me a minute. Okay, and the title of the topic is the types of the solutions, which we have started in the yesterday's session also. Some part of the types of the solutions we have seen in the last class also. If you remember, we have seen different types of the solutions in the last class based on different criteria, like based on the number of component present in it, that is binary, ternary, quaternary, etc. Then based on the nature or physical state of the solute as well as solvent in it, that is solid, liquid or gaseous physical state. Then based on the amount of or quantity of solute present in the solution, that is saturated, supersaturated and unsaturated solution. So these three types we have already discussed in the previous class. Now in today's class we will see first of all the examples for the solutions, simple examples in day-to-day life, examples of solutions are nothing but the homogeneous mixture. We have seen that part also in the last class. So first is the sugar solution, or I will write down aqueous solution of sugar. The word aqueous stands for, it is the solution present in water, right? Aqueous solution of sugar. Okay, if you have any questions in mind related to this topic, you can just let me know in between. I'll just send a message hi here, so that just a minute. Okay, so this is the first example, aqueous solution of sugar. So in this aqueous solution means solution of something in water, right? Okay, so for that purpose I will write down what is the solute and what is the solvent in it. Solute is that part which is present in the small quantity, therefore sugar is the solute in it, right? Sugar is the solution solute in it, whereas solvent is that component of the solution which is present in the large amount, right? Therefore water, as it is aqueous solution, water is the solvent, so water is the solvent present in this solution. So this was the first example for solution. Next example I will write down now. Second example is tincture of iodine. TINCTURE of iodine. Now tincture of iodine is also an example of solution in which the solute is iodine and solvent is iodine and solvent is alcohol, ethyl alcohol. Okay, so this is also an example of solution. The tincture of iodine, solute iodine, it is the solution of iodine in alcohol. Third example I'll write down is air. Okay, now in case of air, as we know, the major component of air, the two main components of air are oxygen and nitrogen, right? So here we can say oxygen and nitrogen collectively they are nothing but what you can say, the solvents, as they are present in the large quantity. As we know, there is a 21% of oxygen in air and the nitrogen N2 gas, there is 78% of nitrogen in air. So these two are the solvent and all other gases. What are the other gases? Helium, H2, neon, argon, then water vapor, carbon monoxide, carbon dioxide, nitrogen dioxide, etc. Okay, all these gases are nothing but the solute here, right? So this is how these are the examples of the different solutions. You can just take a screenshot of this page first of all. Let me check. Okay, I hope you understood these examples. Now let us see some other things, or let us see now the properties of the solution. Next point we are going to discuss about solution is their properties. Properties of a solution. Okay, yes, let us see the properties of a solution. So first property, one by one I'll write down all the properties. So first property, as we have already discussed, a solution is a homogeneous mixture. Solution is homogeneous mixture. This is the first property. Second property I will write down now here only. The second property, the size of the particles. Size of the particles of a solution. Size of the particles of a solution is lesser than 1 nanometer in diameter. 1 nanometer in diameter. 1 nanometer is equal to 10 power minus 9 meter. Therefore, particles of a solution are not visible to naked eye. Okay, the next property after this, they do not show, that is particle, they do not show the scattering of a beam of light passing through the solution due to very small particle size. Therefore, or hence, the path of light is not visible in the solution. Is not visible in the solution. Okay, so this property we can check at home as well. Like we can take a solution containing the sugar dissolved in water, aqueous solution of sugar, and we can just hold the battery just next to the glass. We will not see the ray or beam of light passing through it. Okay, so this is the third property, and then the fourth property I will write down. The solute particles, as they are very small and they are homogeneously mixed in the solution, cannot be separated from the solution by filtration. Therefore, and one more thing, the next property, the solute particle do not settle down when left undisturbed. Therefore, we can say the seventh and last important property, we can say thus solutions are stable. Okay, solutions are very stable. So these are the properties of a solution. You guys can take a screenshot of this page first of all. Yes, now after the properties, we are going to discuss about the next part from this chapter. Just go to the next page. Okay, and the next property which we are going to discuss now is concentration of the solutions. Concentration of the solution. Okay, now first of all, what is the meaning of okay? Yes, now what is the meaning of concentration? First of all, we are going to discuss that part. Concentration of solution, right? Just like I have given one example to you, like if I am talking about a solution, three different solutions. One is the unsaturated, another is the saturated, third one is the super saturated solutions, right? In case of unsaturated, the lesser than required quantity of solution is present, solute is present. In case of saturated, exact quantity is present, and in case of super saturated solution, excess amount of solute is present than required, right? Now here this amount, by if you observe the solution, by observing you cannot tell that is what is the exact amount of solute particle present in it, right? You cannot actually tell what is the number of particles present in it, right? That is not possible. So therefore the term that is concentration of solution is introduced, which gives us the actual or exact number of particles of solute present in the solution, right? Okay, so what is the solution? Solution is the number of or instead of number, first of all I'll write down about amount. The amount of solute particles present in the solution is called as the concentration, is called as its concentration. Okay, it is called as its concentration. Okay, yes, so now that is the definition of concentration. Now there are different ways to express the concentration of the substance. Okay, yes, so concentration of solution can be expressed in different ways. Let us see what are those ways first of all. So these ways are first of all classified into two. First one is called as qualitative method, and second one is called as quantitative methods. Okay, second one is called as quantitative method. Okay, now qualitative means what? It is giving you the idea about quality only, right? Only quality. But quantitative will give you the idea about exact quantity, right? Quantity means exact amount, quality means only what is present, or only about quality you are going to discuss, right? Okay, as far as quality, we can call the solution as either dilute solution. Okay, in case of qualitative method, there are two types of the solution. One is the dilute solution and another is the concentrated solution. One is the dilute solution, another is the concentrated solution, right? What is the meaning of these two words? Let us discuss. So first of all, dilute solution means what? Dilution process means what? Do you remember we have seen the process of dilution is nothing but adding the water to it, right? Like for example, if I am preparing a solution of sugar in water, aqueous solution of sugar in water, if I think that the amount of sugar it is little extra sweet, so what I do, I add water. Adding water means what? You are doing dilution, right? Adding water means you are doing dilution. Therefore, in dilute solution, less amount of sugar will be present, more amount of water will be present, right? That I can write down here. So dilute solution, less solute or lesser solute, and plus what is the greater solvent. Okay, lesser amount of solute plus greater amount of solvent, that is nothing but the qualitative way dilute solution. Okay, do you remember in your science laboratory or specifically in chemistry laboratory, you might have seen some bottles of chemicals on which the label is written like dilute HCl, dilute H2SO4, dilute NaOH, or concentrated CONC HCl, concentrated H2SO4. So what are these? These are nothing but the ways to express the concentration of a solution in a qualitative method, right? Only quality we are going to discuss. Yes, in concentrated solution we are having greater amount of solute plus lesser amount of solvent. Okay, yes, so this is about qualitative method. But from observing the qualitative method, like if you observe the bottles of acids and bases in your laboratory, dilute HCl, dilute H2SO4, concentrated NaOH, concentrated H2SO4, from observing dilute or concentrated, will you be able to tell exactly what is the number of that acid in it, or what is the exact number of base in it, that solution? No, it's not possible, right? Because that is the qualitative way. Therefore we need the quantitative method, right? In quantitative method we are going to express the actual number of the particles, right? We are going to express the actual number of the particles. Okay, so there are different types of these qualitative methods as well. One by one I will just list all of them, and then we are going to discuss them in detail. Okay, first of all, the simple one we are going to discuss, and that is nothing but okay, one by one we are going to discuss. So first one is called as mass by mass percentage. Mass by mass percentage. Second one is called as mass by volume percentage. Okay, apart from that there are other methods as well. I'll just list them, but no need to discuss these properties right now. I'm just going to discuss them here. Okay, ppm. ppm stands for parts per million. Okay, the next is mole fraction. No need to discuss them right now, we are going to discuss them later. Mole fraction, then molarity, then molality. See the spelling difference, there is only one difference, R and L. Okay, and then next is normality. All these concentration terms which I have written in orange color need not to be discussed in today's session. We are going to discuss them in next session. Okay, so you guys can do one thing, just take a screenshot of this page. Okay, I hope you have taken a screenshot. Now finally we are going to discuss few formulas related to the concentration of the solutions, right? There is one simple formula you can remember. If you remember this simple formula, you will be able to remember all the formulas for the concentration of the solution. I will write that on the page first of all. Okay, so yes, so we have learned about concentration of the solution. So I'll write down few things on the board. Concentration of solution is equal to amount of solute. Amount means what? It may be in terms of gram, it may be in terms of ml also, right? And in the denominator it is amount of solution, whole solution. This is the first formula you have to remember. Or one more formula is there. Concentration of the solution is equal to amount of solute divided by amount of solvent. So these two formulas you have to use accordingly, right? Yes, so then two more formulas I am writing here. The question based on these formulas we are going to discuss in the next class. Just let me write down the formula. Mass by mass percentage of a solution. Mass by mass means what? Mass divided by mass. So it will be mass of solute and mass of solvent. Mass of solute divided by mass of solution, right? As it is percentage, for percentage we multiply it by 100, right? So this is obtained mark, this is total mark multiplied by 100. Okay, the same way we find out the percentage marks. Okay, and then the last formula I will write down. It is mass by volume percentage. Mass by volume percentage of a solution. Mass by volume percentage of a solution. It is equal to, so mass will be in the numerator, volume will be in the denominator. Mass of solute divided by volume, right? Mass by volume percentage. Mass of solute divided by volume of solution divided by volume of solution, as it is a percentage, multiply it by 100. So these are the four main formulas to remember. On the basis of these four formulas only the questions are asked. So you guys can just take a screenshot of this page, and the question based on this we are going to discuss in the next class. Take a screenshot, students. I hope you have taken a screenshot. Now it's time to show you about DPP, daily practice problems. So yes, I hope you can see this. So this is about the daily practice problem. Just a minute. Yes, so this is the daily practice problem. This is a teacher's portal. So here what similar will be the student portal as well. So you have to go to the resources here. Then after resources you will go to writing material. In writing material, teacher will add the DPP. So you will be able to see the DPP, daily practice problems. You will be able to download it here and solve the questions and write down solutions on your notebook or piece of paper, and then send it across to upload it on the portal. So then after you upload, I'll be able to solve evaluate it and let you know about the suggestions and corrections in it. Okay, so that's all for today. So we are going to stop here. Thank you so much all of you for your precious time, and all the best to you. Thank you. Bye bye. Take care.